Good day everyone. In this video I will be explaining about the extractor fan design. Ordinarily we have 5 types of extractor fan we do use in the building services industry. We have the ceiling mounted type. Likewise we have the type we do call the true wall extractor fan. We also have the window mounted fans, and we have the inline mounted, and likewise the true roof. The simplest approach for any fan specification or design is to use the air change per hour approach. And what this implies is that you determine the volume of your bedroom or toilet or anywhere you are installing for. So you need to determine its volume, and you will multiply the volume by the air change per hour standard. But in order to understand this, professionals have already specified the air change per hour for every space type. For instance, the air change per hour for normal bedroom is 15, although it ranges between 11 to 15, and for toilet is 10. So you can actually use 6 to 10, laundry is 6 to 10 too. And some other areas, maybe because there is no duct installation, we can use between 10 to 30. These are standards specified by building professionals. In order to be able to apprehend this principle, let's take this space as a case study. We determine the area first. Since we are using a 2D software, so our area for this place is 2.5 meters square, and our building height, you need to go to the elevation given to you by the architect. I doubt this project has an elevation. Let's use this project as a case study. Taking this area as a case study, so we determine the area again, F3, so that we'll be able to snap the edges. Sorry, I use Ctrl Z to control it. So here is it. So we have 2.8 meters square. So you now need to go to the elevation. You come to the architectural design here. So let's MEP. From the elevation design, the building elevation is 3.3 meters. So if probably, and the elevation will definitely stop here. Let's determine this. So let's assume 3 meters. So our building will be 3 meters high. Since we've gotten 2.8 before, so we'll come here 2.8 times 3 meters. That's 8.4 meter cube. And from there, if your country unit is CFM, so you multiply by the standard ACH. So for this our design here is actually a toilet. For a toilet and bedroom, you consider the bedroom more than the toilet. So we have 8.4 already. We multiply by our standard air change per hour. Let's choose 15, but on the norm you can choose between 11 to 15. So we multiply by 15. So we have 126. So this 126, if you are going for CFM, you divide by 1.7. So that gives us 74 CFM. But if you are going by liter per second, so you divide by 3.6, sorry, 35 rather, 35 liter per second. In either of the case, we have 74 CFM. So you will definitely have to round it up to the most readily available unit. That's why in our project here, where is the schedule? Okay, this doesn't have a schedule. We have our schedule here, extractor fan schedule. So I'm having 80 meter cube because this one is readily available. So we use the same principle for every toilet, bathroom, laundries as required. So let's repeat the same process here. Area F3, Ctrl Z. So we have 2.8 by 15, sorry, by, let's assume 3 by 15. So that gives us 126 divided by 1.7 for our CFM unit. So 74 too. That's the reason we have 80 CFM. 80 CFM for our fan nominal performance, and I eventually recommended 100 CFM because of some other considerations. So this is the simplest approach in designing for an extractor fan. And another thing you need to consider in a fan design is that we have two types of fan. We have the conventional fan and we still have the SELV fan. Although the approaches differ, but it's more easier to use the wall through type. So you just place it towards the wall. But although it depends, you might sometimes have a roof through and etc. So hope you find this video educational. Don't forget to like and subscribe. Thank you.